This is a Roomba, the iconic robot vacuum that usually ends up in the back of the closet collecting dust or being sold on Marketplace for $20. But there's so much potential in these things. Motors, sensors, a whole robot just waiting to be hacked. What if we could make it go faster, see through its eyes, and reprogram the whole thing using a $7 Raspberry Pi? Everyone's building apps and websites, and they all kind of look and feel the same, and everyone's using the same AI tools and having AI generate most of the code. But with hardware, it's different. You can't just prompt your way around this stuff. You've really got to get in there and break things and figure out how it works. You could hack your coffee machine so that you can text it to brew you coffee, or control an RC car through a web browser, or just take apart a Roomba because some guy on the internet said it was a good idea. Because that's where the real fun is. Coding something different. This is the Roomba motherboard that controls everything on the Roomba, and it's plugged into the speaker and the charger and a whole bunch of infrared and LiDAR and other sensors. But we are going to completely unplug this from everything and get rid of it because we are going to use a Raspberry Pi Pico and control everything using Python. At least that's the plan. Good thing we have no one underneath us. On the other side of the Roomba, if we look underneath, well, first there's the battery, and I really should have taken this thing out first. And then we can see these 4 motors. There's the 2 motors for the wheels, there's this brush motor thing, and then there's the main motor that actually controls this thing vacuuming. And the first thing I want to do is try and see if we can control these motors. So here is one of the wheel motors, and if we take a look inside of this, if you can look past the dirt, you can see there's a couple of wires here that detect whether the wheel is actually on the ground or not. There's a few wires coming out of the motor itself to tell us how much the wheel has actually turned, and we can figure out how to work with all of these sensors a little bit later on. But for now, all we need are these red and black wires that are coming out of the motor. Because if we connect just these 2 wires to a battery, then the motor will turn. And if I flip around the battery, then the motor turns in the opposite direction. And this battery is around 4 volts, so it was spinning kind of slow. But if I take 4 of these and link them up in series, then I now have a 16 volt battery, and we get a motor that turns way faster. So motors aren't that difficult to control, and that's where we're gonna start. Make a remote control vacuum just by controlling these 4 motors. We're gonna be using the Raspberry Pi Pico to try and control the Roomba, because it is a $7 microcontroller, really cheap, that supports MicroPython, and it has all of these pins on the outside, these GPIO pins. That means that we can write some code that interacts with things in the real world. It supports C and C++ and some other languages. But if I Google programming a Raspberry Pi Pico, Raspberry Pi has a decent amount of documentation on how to get started just writing some basic Python to control things. So we'll start simple. I have this Pico already set up with an LED plugged into pin 17. I should be able to run just a little bit of Python code to set up my LED on pin 17, which is where I've got it plugged in right now. If I toggle this pin now, it should light up that LED, and if I toggle it again, yeah, every time I toggle it on, it's sending 3.3 volts through that LED to light it up, and then when I toggle it again, it just turns it off. And we're basically gonna do the exact same thing, but instead of a light, we're gonna make a motor turn. And I also have this Python script here. It's gonna loop around, and it's going to increase the brightness of the LED gradually and then decrease it back down. So if we run this, we should see, you can definitely see that. The LED is getting brighter and then it's going back down and getting dimmer. So again, we can use this exact same technique to increase and decrease the speed of the motors. But we can't just plug the motor directly in where this LED is, because the Pico isn't going to supply enough power to the motor. It doesn't have enough current or voltage to make the motors turn. So instead, what we're going to do is we're gonna add in this battery pack. We could use the Roomba battery pack if it still worked, but mine was completely dead, so I'm just gonna use this custom one for now. But we take that battery pack and we plug it into this motor controller. And then we can take one of the motors, plug in the red and black wires of the motor, and this thing is just a $3 motor controller that is gonna act basically like a dimmer switch. The Pico can supply that little bit of voltage to this board, and it will allow a certain amount of voltage from the battery to the motor depending on what the Pico is telling this board. So if I plug one of the motor controller pins directly into the same pin that's being used to control that LED, and then I just need one more pin so that the motor knows which direction to spin around in, and I'm going to use pin 18 for that. Plug in the last battery here, and then this motor should turn as long as I remember to plug in the ground connection. There we go. Okay, so now as the LED gets brighter, the motor will spin faster, and then as it gets dimmer, the motor slows down. So this code is controlling the motor. We can control the motors with a little bit of Python. Now the next goal is to be able to control this over Wi-Fi so that I can set the speed wirelessly. So I've added a function that will connect the Pico to my home Wi-Fi, and then I'm using this micro.python library, which creates a really lightweight HTTP server on the Pico itself. So if I run this code again, I can see it's going to attempt to connect to the Wi-Fi. It should connect and then set up an HTTP server running on the Pico. So this is its IP address. I could just try a curl request to that, which is so sick. It's just running an HTTP server there. I could even visit it in the web browser if I really wanted to. There we go. There's my Pico web server working on my Wi-Fi. But to control the motors, I've set up a custom motor class, and it takes 3 pins. These 2 are for the direction, and this one is for the speed. Then I've set this up as a WebSocket route. I'm just expecting a 1 byte binary integer. -100 is full speed backwards and +100 is full speed forwards. So it's going to expect just that tiny bit of data to come in, and then it's going to update the speed based on what it gets. So I just need to create a WebSocket client for this so that I can start controlling the Pico. And for that, I have set up a React app. It just connects to the Pico WebSocket server and then has some components to send that data up. So if we open this in a web browser, this is what it currently looks like. I got a little toggle here. So if I toggle it up and we look at the light and the motor, we should be able to see them. There we go. There's the motor turning, and that's 100%. And the light also lights up still because I got them connected to the same wire. And you can see it working in both directions. You can see it logging out the values on the server of the Pico too. So this is browser controlled Roomba, and it won't turn off. I don't know why. Must have put a bug in there. Now I just need to clean up the code a little bit and get all 4 of these motors connected up to these motor drivers. This whole part here is the part that picks up all the dirt, and that's these brushes that are responsible for it. On the back of this thing here, right here, this silver thing is the motor. It's the silver part on all of the pieces that's the actual motor, and again, we're just looking for these red and black wires. That's all we need to control this thing. And the way this works is that the silver part is the motor itself that we apply the voltage to, and then somewhere in the plastic part there's going to be some gears that then make this part turn with a little bit more power. And then the second wheel motor. And again, here is the motor, that's that part. There's the red and black wires somewhere. And inside this piece right here, there's a whole bunch of gears that reduces the speed of the wheel, but increases the torque, which makes it much better for driving. And then finally, this brush motor, which actually doesn't have any wires on it. It just has these 2 pads. So I think I'm gonna have to solder a red and black wire onto this thing. All of the motors have now been attached back to the bottom of the Roomba. I have all the wires coming out from the bottom to the top here. Each of these can control 2 motors individually, so I just need 2 of them for all 4 motors, and you can kind of see these red and black wires coming up and plugging into each of those, and then the Pico is plugged into each of those controllers individually. And I also added this little 5-volt converter here, so I can attach any battery to this and it will make sure that the Pico just gets the 5 volts that it needs. I also added another cell to the battery pack, so it's 5 now, so it's a 20-volt battery, which is kind of the equivalent of just plugging a drill battery straight into this thing. And on the code side of things, I've now got these 4 motors on the server for the right, left, the brush, and the vacuum. And in the WebSocket code, the server is just listening for these speeds to come in. And then it's just going to update each of the motors based on the values that it gets. And I could control all of this from a React app, from a web browser still, but I thought it would be much more fun to control all of this from an iPhone app, because I can actually connect this to one of the game controllers built for iPhone. And then in Swift, I can just import this game controller library where I can just detect these left and right joysticks and then send that data to the Pico WebSocket server. So if I push these back and forth, you can see those values. These toggles will be for the left and right motors, and then I just have this slider in the middle to control the vacuum speed. So now really the only thing left to do is test if this actually all works, and I should probably test that on the floor. Go ham? Oh my god. Oh, did you see that? The fuse just burnt out immediately. I drove it 2 inches. Oh, that's so stupid. The good news is I had a fuse on the battery in case anything went wrong. The bad news is I just immediately blew. So let's see what happens if I actually... Oh, I blew again! I think I might have something wrong with my circuits. I mean, it feels like the red and black wires are shorting. And if they are shorting, that would also explain why the fuse is blowing every time. But I don't even know how. Oh, that could be shorting them. Okay. I think that's normal. I think I fixed it. I think I'm a genius. I'm a little scared to try it now. I think the right motor's okay. Alright, so let's try. Oh, wait. It's working! Oh, that is so sick. Turns so nicely. Oh my god, that's so fast. Imagine if Roombas were like this. They'd be terrifying. That is... that is so much fun. Oh, that's so good. And with the vacuum on? Wait. Oh, so loud. That is so loud. Be so fast at cleaning though. Hell yeah. Okay, this is awesome. Oh my god, I love this. Now, I know there are so many more things I could do to make this a better vacuum and integrate some of the other sensors that I've been ignoring for now, but the only thing I want to do right now is attach a camera to the front of the Roomba, live stream that to the iPhone screen, so I can get this first-person perspective of what the Roomba sees. But before I do that, let me tell you about this video sponsor. Because when you're hacking a Roomba, it is really important to have good programming and problem-solving skills. And you can build these skills right now for free using Brilliant, where you learn by doing with thousands of interactive lessons in math, data analysis, AI, and programming. Each lesson is filled with hands-on problem-solving that let you play with the concepts interactively. So you learn by doing, which makes it fun, but will also help you build a better understanding from the ground up. And while you're learning, Brilliant is helping you build these critical thinking skills through problem solving. You're building real knowledge on specific topics, and you're becoming a better thinker and problem solver. And my favorite part is that you can do these lessons whenever you have time. Get started with just a few minutes every day and try out their mobile app to make that daily habit even easier. You can have a lot of fun leveling up in Python while also learning how to build a language model. So to try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/Sam Meech-Ward or scan the QR code on screen. There's also a link in the description, and you'll get 20% off an annual premium subscription. It looks like the Pico isn't really designed to work with cameras, so there's not much selection, but I found this camera right here. It's an OV2640, which is a really standard camera to use with a microcontroller, but it's $26 just for this module, so way more expensive than the Pico. And that's because the sensor right here, the camera itself, is a fairly cheap piece of hardware. I think you can get them for like $5 on AliExpress, but to get it to work effectively with the Pico, they have to add all this other expensive stuff. But I've got one right here, and we just need to plug it into the Pico and see how this thing works. Here is the camera plugged in, taking up 8 of those Pico pins, and we can quickly test this out by taking a picture on the camera and serving it up over an HTTP request. So I got some camera code from the camera's website. It's just a big Python class that handles setting up the camera and everything. I'm setting it up to take pictures at 640 by 480 pixels. And then I have this HTTP endpoint. So when we go to /JPEG, it's going to take a single JPEG image from that camera, and it's going to return it as a HTTP response. So if I run this code right now, we should just be able to take this IP address and go to /JPEG to see a picture. Oh, all right. That's working. So I'm going to hold this up a little bit higher in front of my face, and if I just keep refreshing, I'm going to keep getting a new JPEG frame. So All right, this is kind of like really crappy video, but that was pretty easy to get set up. Now, what I really want to do is instead of having it be a JPEG each time, I really need a video stream. So if we look back at the code, I have a different endpoint here that is /stream, and this is just going to be an MJPEG stream. So I can still just visit it in a web browser, and essentially instead of just sending back a single image, it's going to continuously keep taking images and send that down as an HTTP stream to the browser. So if I go to /stream, okay, so there's the video stream, and it is really laggy. That frame rate is awful, absolutely awful. Hold on, if I just focus, it's kind of okay. All right, and that's really just due to the limitations of the technology we're using. So if I go back into the code and I reduce this size, so instead of 640 by 480, we're going to go with 320 by 240. So it's going to be much smaller images, but this should give us a much better stream. Yeah, there we go. Okay, so that's a little better. It's just need to reduce that size. So that's pretty decent. We're getting a stream. We're just streaming JPEG frames. So this is what it looks like on the iPhone. I am getting that real-time video feed. If I hold it up a little bit, you can kind of see my face there, yeah, coming through on the iPhone screen. So overall, not bad at all. And I have these LEDs on the Pico right here to kind of simulate the motors for now, so we can see that I can stream this real-time video and I'd be able to control the motors at the same time. So that all still works. I'm getting this little bit of a live stream, and I mean, it's working. That is working, but we can do better. And this is an ESP32S3, which is about the same price as the Pico, but this board is set up a little bit better for doing things like video streaming. It has more RAM, it's got a faster processor. So to get a bit of a better video stream, I'm going to use one of these and see what the performance difference is like. And I went and got this version of the ESP32S3. It's from Seed Studio. It costs $14 and comes with the same camera that we're using over here. It's the same sensor module, but this entire thing costs $14. So we've got a cheaper setup with a more powerful processor, and we could stick with MicroPython for this, but I find it incredibly easy to use C and C++ with the ESP IDF. So I've rewritten the app, and it does basically the same thing, but instead of 100 lines of Python, it's like 2,000 lines of C and C++. So for the camera setup, I'm using SVGA, which is 800 by 600, so more than double the size of the image we were getting with the Raspberry Pi Pico. And we're basically doing the same thing, where we're going to grab a JPEG frame from the camera on the ESP, and then we're going to send that over the WebSocket connection so that the client receives each JPEG frame as a separate WebSocket message. And I'll post all of this code on GitHub if you want to take a look through the entire thing. But let's plug this in and run this application. And here it is on the iPhone stream. I'm going to hold this up a little bit. And that is definitely a crisper shot. The frame rate is so much better. And we're just all around getting a better video stream in this tiny little package, and only $14. And I'm just going to show a side-by-side comparison of this video quality difference, because the Pico is great, but for video streaming, clearly here there is a winner. This is the Pico camera. I've got the camera attached right there with some double-sided tape. And I think this is ready to go. And for the ESP, I didn't want to take the other Roomba apart, so I just put together another one. So it's got the battery pack the same. The ESP is at the front there with the camera. I got an antenna on the back to get a little bit extra range there. And I managed to get all of the electronics inside of the empty compartments here, like where the battery used to go. So it looks a little bit cleaner too. Now let's see if they actually work. Okay. I always forget how fast this thing drives. That camera feed, that is sick that the camera is working, but it's incredibly difficult to see what's actually going on when I'm driving. And I don't know, if I completely stop though, like this could be an okay spy cam or something. It is sick that I have a live streaming camera on the Roomba, but I think I need to try with a better quality wide angle to see what this is like. So that's the wide angle camera. Oh, that is so much better. That is sick. That's actually way better than I thought it would be. My God, I can actually drive this thing just using the game controller screen. That really exceeded my expectations. Are you ready for the cleaning test?
What's that? What is that? What the f is that? I hate you so much.
Are you ready?
Where did you get that?
Are you ready?
I hate you.
Are you ready for... No, it's okay. The Roomba's going to clean this up. You ready?
I don't believe you.
What the hell? Hey. Oh, I really hope this... Oh my god, it's glittery. You ready? Vacuum mode.
Can you see the sprinkles?
I can see, yeah, like through the camera, I can see exactly what I need to clean up. I need a reverse camera too, so I can see what I've already cleaned up. You know, like, this is cleaning just as well as it did before I hacked it. So that's impressive on its own. Full speed mode with the vacuum. Oh yeah, that is no problem cleaning this up. Oh, hell yeah. I don't know why Roomba doesn't just put live streaming cameras on all of their robots. This is so sick. Let's see how good a job the Roomba did. See? That is still a decent vacuum. That is so sick. That's awesome. Okay, you get to clean all of this up, right? And I really wanted to test out the Pico cam as well, but something happened when I plugged it in and a bunch of smoke came out around here and the fuse blew again. So this one is officially broken right now, but we have to move on because it turns out we can just plug a microcontroller straight into the Roomba's motherboard using this port instead of having to rip everything out, which is great because these motherboards have already been set up to be able to work with all of the motors and the sensors inside of the Roomba. You can see the port on the motherboard itself and it appears right here on top of the Roomba. And all we have to do is connect 3 wires into these ports from the microcontroller. And now these two can send messages back and forth over these wires using the Roomba Open Interface, which is a serial communication protocol that is really well documented. There's commands for everything you can do, like controlling the motors, getting data on any of the sensors, and there are a lot of sensors on the Roomba. And you can even program a song into the Roomba using these different notes and then have the Roomba play that song back to you. And I'm embarrassed to say that I had no idea this existed until Wes Boss casually mentioned this to me and then made a video on how to control a Roomba using JavaScript where he goes over all of this in way more detail. But I've got my microcontroller plugged straight into the Roomba. The red and black wires go straight to the Roomba battery so I can just use that power. And then the green, yellow, and blue wires are all for that communication. And I've got them plugged in to my ESP over here. And I just made my own little circuit board to clean that up a little bit. And I have my voltage converter, so it's going to take whatever the Roomba battery's giving and convert that to 5 volts for the ESP. The ESP's got that wide angle camera lens on it. And then I've still got the little antenna on the back of the Roomba. But this is definitely looking like the least dangerous version of my Roombas so far. All right, you ready? Do you think this is going to work? So this controls pretty nicely without having to hack the whole thing apart. It's definitely slower than my custom versions because we're not just hooking up a custom battery straight to the motors. But with this version, because I have access to all the sensors on the front, I've implemented that video game style crash. I can see how much current each motor is drawing. And I have a list of a bunch of other sensors that I want to integrate into this app. And there are so many sensors you can work with. But my absolute favorite